I have the opportunity here to present some of my recent research, and this research is also practice oriented. It's not very theoretical, part of this research is shared work with Thorsten, a colleague from the environment design chair, and I also got a lot of support from other colleagues. Thanks to Edward, Paul, Chile, and Vincent, they provided me a lot of valuable information and literatures. And my presentation is about the passive house application in affordable housing. And this topic is mainly related to technology and also related to the social issue. It includes two cases of European countries and the application, the feasibility of the application in Korea and China. And as we know, the global energy price were rising rapidly in recent years. Although the oil price had dropped for a period of time last year because of financial crisis, and it has came back to a high level recently. From a long-term view, the energy prices will be still on the way up. So these two illustrations show the trends of the electricity prices and the gas prices in the Netherlands and in Europe in recent 15 years. The blue curve represents the situation in Europe, and the yellow curve represents the situation in the Netherlands. So you can see that the increase of the energy prices in the Netherlands is obviously faster than that in Europe. And for those mid-low income families living in the social housing in the Netherlands, the household energy bill is becoming an affordable burden because of the high energy price. And the results show that for 80 square meters social housing units, the household energy bill is around 3,000 euro per year. That is almost 10 to 15% of the family's gross income. So a lot of families living in this kind of social housing have to reduce the energy bill by reducing the thermal comfort of the rooms. And this situation caused some social problems. Although the rent for social housing is low in the Netherlands, but the maintenance cost will be high because of the energy bill. So in the coldest month in winter in the Netherlands, the household energy bill could be even higher than the rent. So this phenomena is quite opposite to the social housing policy, I think so. So some sustainable social housing approaches have been adopted by the housing association in the Netherlands to solve this problem, such as the energy efficiency renovation and the new construction, and the housing management and tenants education. And here I'd like to introduce social housing renovation and new construction, energy efficient renovation and new construction method through passive house concept. A passive house is a building in which a comfortable interior climate can be maintained without active heating and cooling systems. That means the house can heat and cool itself, so we call it passive. Generally there are four basic features for passive house. The first one is the good insulation for buildings envelope. Good insulation for buildings envelope, which is the most important and effective measures. And the second one is the energy efficient window glazing and the frames. And the third one is the building envelope air tightness. And the fourth is the heat recovery from exhaust air. And these measures are not high-tech, but the adapted technologies. So they can provide the possibility to achieve both the energy efficient and cost efficient goals for social housing. There are two fundamental requirements for passive house, especially the certificate passive house. The first one is the heating energy consumption no higher than 15 kilowatt hour per square meter a year. And the second is the primary energy consumption, including the heating, hot water, and household appliance, no higher than 120 kilowatt hour per square meter a year. And this is the so-called passive house standard. And the first case I want to introduce is the Roosendaal social housing renovation. And the existing buildings in this project are all two-story row house. This is the image of the renovated house. It was composed of two housing units. And from the picture, you can see the roof and the outer wall are obviously expanded from the existing building's roof and outer wall. And this building envelope expanding is caused by the insulation addition to the roof and the exterior wall. The original wall of the building is two-layer brick wall. In the renovation, the outer layer of the existing wall was removed and replaced by a 20 centimeter extruded polystyrene insulation. And this is the process of this replacement. And from this picture on the right, you can see adding the insulation to the exterior wall and the roof. It is quite a simple and effective method, just like people wearing heavy coats in winter to protect cold directly. The original windows in these existing buildings are steel frame, single glazing windows. In this renovation, the wooden frame and the triple glazing window was adopted to replace the original window. This is the section of the wooden frame. You can see there are several insulation layers in this frame, and this insulation layer can improve the overall performance of the window. And this illustration shows the facility system in this housing unit. All the facilities were installed in the attic of the housing unit. The heat in the exhaust air can be recovered in the heat recovery air handling unit and transfer this heat to the fresh air. And the fresh air can be further preheated by solar energy and distributed to every rooms in this housing unit to keep the room temperature